1, 2, 3, 4, 5. I think we're live now. 1, 2, 3, 4, 5, and we are live. Should be some people out there, hopefully listening to me right now. Hopefully listening to me. Just going to get my remote control out. Connect to Mundo. Get my Teams out so I can answer questions. Ping me in the chat if you are listening. Great to have a nice audience out this morning on this fine Monday morning. Down all the way down here in Canberra. Still pretty chilly, but not too rainy today, which is great. I can see I get a thumbs up from someone. Thanks, thumb up person. Oh, thumb up from 4. We've got 4 people watching. That's great. I'll just leave it another minute or 2 before starting our lecture for today. I might actually start my recording today. I didn't record it the other day on Thursday, which can sometimes be a bit of an annoying thing to happen. I always can get the recording back from one of the many places I stream to, but if I don't have it on my computer, it's not as easy to put on Echo 360. So I should be able to fix that for you by this afternoon for the Thursday lecture, but sorry about that if you were expecting it on Echo 360 and it didn't come. I'll be there soon. G'day folks, welcome to Monday's lecture, week 3 in Comp 1720, 6720, Art and Interaction Computing. I hope you are all having a good start of your semester. Things should be starting to settle into a rhythm for you. Now that you've got your classes organized, you know what you're doing, your enrollments are all organized, all of your labs are organized, you've started to go through the basic requirements of each of your different lectures. Whoop, let's make sure I'm seeing myself here. I want to see the audience view. Where's my audience view? Oh, there I am. I know that I'm definitely visible to you now. Make sure my Teams is on top. Today's lecture is on the topic Conditionals and Iteration. We go through a kind of whirlwind of coding topics in this first few weeks of Comp 1720, 6720. For many of you, conditionals and iteration will be something you've looked at before, perhaps in another computing course or in some other coding you might have done in high school or somewhere else at uni. But we will go through these topics again in this one lecture, particularly for the folks who have never done any computing before and just need to get started. And you'll start to see this lecture how conditionals and iteration are what give you this amazing power with programming languages. Iteration with eyes. Amazing power with programming languages to do much more than you can if you would just have to do things manually. So this is the secret sauce that makes computing powerful, being able to set a program to do multiple things, make decisions for you, follow instructions, tell it what to do, without having to be super precise and specify every single thing. This is what helps us to make exciting and interesting works of art. This is what makes these computer programs fun to make and fun to look at. But you know what? It's also what makes things frustrating and difficult to debug and make them drive you insane. So, you know, it's goods and bads, but hopefully more goods than bads. I'm just going to skip this synopsis slide. Who even needs synopsis slides? I think we should delete them all. Admin corner for this week. I'm just going to make myself small. Hopefully it did it. Yeah, I think it's done it. I'm going to assume it's done it. Admin corner. First thing, very, very, very important. Assignment 1 is due on Monday, next week. You have 7 days left to complete, well, I suppose 8 days left to complete assignment 1 because you've got most of the Monday. We will have a big assignment 1 discussion at the end of this lecture. So I'm just going to save a moment to go through that. But if you haven't been to the assignment 1 page, I think now would be an excellent time to do it. The assignment 1 page is here on the website. Oh, the website's all new. We changed the website completely last week. It's quite a bit different than it was before. We're going to look through this whole page at the end. But make sure you go and look at it. If you haven't looked at it yet, look at it now so that you are ready at the end of the lecture to ask a question. Remember that you have everything you need to do, all the knowledge you need to complete assignment 1. The only thing left for you is to use your creativity at putting these tools together in an interesting and exciting way. In particular, all of the technical knowledge you need for assignment 1, you've already practiced multiple times. You've been using the GitLab system, you've been cloning repositories, downloading them to your computer, and then pushing them back to the GitLab server. This is the way that you submit your assignment. And the one thing I'm here to tell you, the absolute most important thing with your assignment is to start early and push up a version of your assignment, an early version, and you'll be able to see that everything is working. I'm going to be checking later today to see who in the class has actually already cloned their assignment and maybe has already started it and pushed up a work in progress. And I'll be emailing or sending messages through Discord to everyone who hasn't done their starting version of the assignment and hasn't cloned it yet. So we've got lots of ways to help you get started with that process. Get help videos, your tutors are here to help you. I know people have trouble with this, particularly when they're working with GitLab for the first time. But what I can also tell you is that everyone in Comp 1720 does succeed with this. We don't have anyone who bombs out of this course because they can't use GitLab. All the support is here. We're all ready to help you, and you will be able to do it. Course reps. You know, I've been advertising for some course reps for the last couple of weeks. I've had a few expressions of interest for course reps. They're now listed on the Getting Help page. See this Getting Help page? I've put this in the new website. The Getting Help page is like pride of place at the top right. It's the most important page on this website, really. If you don't know what you're doing with this course and you don't know how to figure out what you're doing, go to the Getting Help page and it will have a suggestion for you. One of the suggestions is to talk to a course rep. We've got 4 course reps here, Bowen, Cecilia, Oyas, and Sneha. I'm really, really thankful to the course reps for volunteering. I know that course reps do a little bit of training in order to know what to do as a course rep. I think that's something which the college will be organising with them this week, but I hope that they are ready and waiting to listen to your concerns, any issues you might have. You can contact them on the forum or Teams or email. You'll figure out a good way to get in touch with them. Particularly if you've got a concern that you don't want to talk to your tutor or me about, that's something you can talk to your course rep about. Maybe you just want to complain about something and have that kind of anonymous complaint sent to me. That's great. If you feel that there's something that's not meeting your expectations and you want to tell us about it, but you don't want us to know who you are, I'm perfectly happy to have that feedback. And often when we do get that feedback, we're able to look at it, see something from a different perspective, and make it better. So do talk to your course reps with any issues that you might have about the course, and they will also be helping over the semester to run some surveys and see what everyone is doing, or how everyone is doing. Yes. Little recap, important information about flow. You remember in P5 that we have these 2 code blocks kind of set up in all of our P5 JavaScript files, our sketch.js files. One is called setup and one is called draw. And it's very important to know that the setup code runs once and the draw code runs over and over and over and over again. And we call that the draw loop. And this seems simple, but it's very important to developing your understanding of programming languages, of computing systems, to know what happens when you run a program. It's deceptively simple, but it can really trip you up sometimes when you have more complicated programs. The concept of knowing what is happening when, the order of operations. The second thing which we have worked on this last week was the concept of variables. Variables, what's that? Well, it's a way to give a name to a value, give a name to a number, and we call it variables because these numbers can then change. Changing numbers. By the way, we can also have a way to give names to numbers that don't change in programming. We usually call that a constant, but mostly in our programming experience in this course, we're just going to use changeable variables, variables that can be modified by you, they might be modified somewhere else, and you know now that we have variables you create, you can give them a name that you invent, and we also have variables that just exist in P5, like mouse X, mouse Y, window width, window height, width height, these kind of things, or frame count. They're variables that change, but you don't get to change them. Some other part of P5 changes them for you. Someone just asked me an excellent question. Is there a way to stop the draw loop? There is actually. I'll just get my pen out. If you use this command, no loop, that will actually stop the draw loop. So if you don't want things to loop, you can just call no loop and it will stop. No loop. And then if in some way you're in a situation where you can start it again, you can just call loop after that and it will do it. Not sure of exactly why you'd want to do that right now, but there are certainly good reasons to want to start and stop the loop. Someone's saying too late, they answered it in the chat. Well, it's good that you've answered in the chat, but I would also like to answer it on the screen for the folks who are watching this after the fact and maybe can't see the chat. Someone said, is there going to be a prize for the best assignment one? I don't do prizes in this class. I like to celebrate everyone's artworks. I like to celebrate everyone's artworks no matter what the mark is, actually, because I know people express things at different levels or in different ways, and the mark is only one aspect of that. So what we do is we'll create a website which will have a big listing of everyone's name tag at the end of the assignment. So do something which is nice enough to be displayed on a big page with everyone else's. It'll just be a fun way for us to see what the whole class is doing. And I think people really enjoy that. I hope you would all enjoy that and find that inspiring after the assignment to see all of the other different takes on this assignment. And there are 230 people in this class, so there's going to be a lot of name tags on that page. You'll see the huge variety of ideas which people have. It's quite amazing and inspiring to do a task and then see this big gallery of everyone's different attempts. So you should all find that fun. Flow, we talked about this last week. This is the path that the running program takes through code. Sometimes you can jump around and jump back, but within the setup and draw loops, it's very predictable what the flow is going to be. Someone's made a good suggestion about the assignment. They think 800 by 800 is too small. Well, that's the assignment. It's constrained. We talked about constraint in art the other day. There you go. We talked about types and another concept related to variables. Types, so far, we've looked at numbers, mainly. 42, 3.14, 106. We've also got some variables like height, mouse Y, frame count, which contain a number. There are some other types that we're going to look at over this course, but for the moment, we're basically dealing with numbers. Now, today's work is to look at these two concepts, conditionals and iteration. These are big concepts in coding, so it's something which you're going to need to pay attention today, try to internalize what's happening through some little examples, but also you need to practice them a lot, and we will give you a lot of practice in the labs, probably starting mainly next week actually. The labs this week are kind of focused on what we did last week in lectures. So the more that you practice these ideas, the better you will get, and I'll tell you about some of the tricks you might need to have a look at in your own time. But once you know these two concepts, basically all of the examples in the P5 website will make sense to you. All of the examples in the textbook for this course will make sense to you, because it's really the same one of the fundamental ideas of programming, this idea of repeating chunks of code or choosing which chunk of code to run at a certain time. So let's get into the first topic, conditionals. What's conditionals? What's a condition? A condition is sort of a state about the world, right? My condition is bad. So I'm in a bad mood or I'm sick or something. My condition is good. I'm in a good mood. I'm fit and healthy. So it's a state about the world. The condition of this item on eBay is poor. It has been dragged through the mud and left out in the rain for 32 years. The condition of this item is mint, right? Mint condition. It means something is in perfect condition. So it's a state of something. And we use the word conditionals in programming to refer to a way where we check the state of something and then use the result to make a decision. So in this image, the inspirational image I've got, there's this guy who's standing. He looks like a programmer. He's got a programmer's uniform on, a t-shirt, black jeans, sneakers, slightly daggy backpack, a cap, baseball cap, classic programmer look. He's got a choice to make. Is he going to turn left or is he going to turn right? And if he was representing a computer program, it might be saying, am I going to run these lines of code or these lines of code over here? We could do either one of them. And the choice could be based on some kind of personal decision. If I run, I can make the train stop on time. Am I capable of running? Would I like to run? I'm choosing it based on some personal decision. If I have a spare month, I'll read War and Peace. I guess that's more of a prediction. If I start assignment 1, I'll start assignment 1 when I finish Netflix. Have I finished watching Netflix yet? No, then I'm not going to start assignment 1. These are all sort of checking the state of internally, externally, checking the state of things in order to make a decision about what to do. And that's what we mean by conditionals here. So checking the state of something and then making a decision based on that. So what do I mean by the state of something? We can make this concept a bit more precise. And by precise, I mean when we make one decision, we really want to we might have a fairly complicated kind of process to get to that decision, but at the end of the day, it will boil down to a yes or a no, right? If we get maybe, that doesn't help us. We really only need a yes or a no. So the concept is to have a value which only has two kinds of outcomes, yes or no. And in computing, we refer to this kind of value as called a Boolean. Why do we call it a Boolean? Well, it's a number that can be either true or false, has two values, and the Boolean part of it means that it refers to George Boole, who was a mathematician and worked out ways to, or set down ways to do maths with two valued numbers. It sort of doesn't matter in some ways what those values are, just as long as you know that there are only two of them. And in the case of conditionals, we do refer to them as like the yes case or true, or the no case, the false case. If we had three values, it wouldn't work, right? We only can choose between two things in this particular construction. So Boolean, this is how we spell it. Capital B, O-O-L-E. This is the gentleman's name. Bool. And then and, Boolean, to refer to things that relate to him. So, Boolean variables. It's something you can make in P5. And they only have two values. One is called true and the other is called false. They're not called 1 or 0, they're not called up and down, although they could be, right? It doesn't matter. But they just have these particular names, true or false. You can easily make one just in the same way that we did the other variables. Let, bool variable equal true. That will just be making a Boolean variable with the value true. In general, though, we tend not to make them as much as sort of just know that they exist. I'll show you what I mean in a minute. Here's some Boolean variables. I didn't need to write them out at all. Var, the sky is blue. Oh, I left the vars in. I should have changed them to lets. I'm changing all the vars to let in this course. Sorry about that. Just pretend it says let. Let the sky is blue equal true. Let the sky is red equal false. So two Boolean variables. And this is the bit where I said you don't exactly always declare them. Sometimes we just have kind of Boolean. Where's Charles? Where are we to go? I don't know where we to go. I don't know where am I gone? Am I still visible? Someone had a really, no, I think I'm there. Cryptic message occurring in the chat. You can do a kind of maths by combining multiple Boolean variables together. You can create Boolean variables by using certain operations that result in a Boolean variable. Here's a list of these particular ones. Less than, so if you had two variables, maybe one was 1 and the other one was 10, and you said 1 less than 10, well, that's sort of a statement, right, in the English language, but in the computer, it's a statement that evaluates to a Boolean number, and that Boolean number will be true, because in fact 1 very much is less than 10. We have another couple of important ones, less than or equal to. This is one that we don't see so often like in regular English language, but we use all the time in computers. So 10 less than or equal to 10, yes. That's evaluates to true. 9 less than or equal to 10, also yes. 11 less than or equal to 10, no, that's false. Greater than and greater than or equal to, the same two ideas. If we want to take two numbers and compare them and see if they're equal, we use this logical expression, the double equals sign. That means equal to. The reason we have to do the double equals sign is because, as you know, when you're creating a variable, let x equal 10, you've used your single equal sign already. So we need to have something else to compare two numbers. X equal y. Otherwise, we would be assigning x the value of y if we only had one equals sign. And we don't want to do assignment, we want to do comparison. Finally, not equal to. It's checking if numbers aren't equal to each other. I'll show you lots of examples where we use these kind of logical operators, but this might be a good slide to come back to if you're not familiar with these operators. Here's one way of creating some Boolean variables using these operators. So the first one, we're creating a variable called x is small. Mouse x less than 100. Second one is a variable called y is big, mouse y greater than or equal to 500. So we've got a variable, mouse x and mouse y. These two contain a number, they each contain a number. And then we're using a logical operator with another number, a written down number. We call that a literal number in computing, in programming. So mouse x less than 100 is going to give us a Boolean. Do we know what its value is? Well, no, we don't know what mouse x is. But we do know something. We know that its value is either going to be true or false. There can be no other option for mouse x less than 100. Same idea, mouse y greater than or equal to 500. We don't exactly know what that is until we're running our sketch and seeing where the mouse is in the page. But we do know that the greater than or equal sign and 500 will let us create this Boolean value. It's either yes or no, either true or false. Here's another one. This is a bit of an extension so far. You saw that we had the not equal to Boolean logical operator on the previous page. So if you have an exclamation point in front of a Boolean value expressed as a literal, not true, exclamation point true. So, you know, it's so embedded in my brain that what this means that I just read it straight off. Exclamation point true, the way to read that is not true. That's a really handy one, using the exclamation point to take the opposite of a truth value. Very, very handy. You'll see why soon. You can also combine logical expressions. We're doing a little bit of a lecture on all the possible logical operators here. These combination operators are very useful as well if you've got two things you want to check. The two ampersands equals and, so you're combining two Boolean operators together. This one equals or, and not is a unary operator that negates whatever it is. Do I have examples for those? I hope so. Yeah, I've got examples on the next page. Just by the way, someone's asked on the chat, when do we use the 3 equals sign? Oh boy, that's one of these JavaScript things that I just can never quite remember how to do. So give me a website to show on the screen, Gene, and I'll bring it up. So, combining Boolean expressions, the 3 equals sign one is just a bit too much for right now. Combining Boolean expressions with these 3 different operators. Let's take the last one first. That's actually kind of the easiest. If we've got a Boolean variable, the sky is blue, it appears that at this moment in my location that's true. It is in fact blue. So exclamation mark the sky is blue means not the sky is blue, which means not true, which means false. Yeah, Jean has just explained and reminded me what 3 equals signs is. It's too complicated to do in this lecture. It'll wait for later. We'll get back to 3 equals signs. So not sky is blue, in my case is false. It's a unary operator. It's an operator that takes one argument, right? And it just swaps the truth value. The sky is blue and the sea is red. Well, okay, in my location, sky is blue, that's true. The sea is red, well, that's usually never true, so I'm going to say that's false. So this is going to be true, one true thing and one false thing. Well, they're not both true, so my answer to this one is going to be false. I'll just write this in and we'll see if we can get this right. Ones on this side are true, ones on this side are false. So this one is going to be false. Sky is blue or the sea is red. So this one's true, this one's not. Sky is blue or the tree is red. Well, that suggests that that should be true, right? Because we've got one of these values being true. I don't know if you've ever thought about these Boolean operators before, but there's the strict interpretation of what these mean, and or. For two things that are anded together to be true, they both must be true. So if the one on the left is true and the one on the right is true, then the answer is true. If you've got an OR operator, either one of them could be true or both of them can be true. Sky is blue or the sea is red. If that's true and that's not, we get true. If this one's true on the right-hand side and this one is false, we still get true. And if they're both true, we also get true. The only time when we get them false is if they're both false. And there's a way to kind of express these called a truth table. I'm probably preaching to the choir here with folks who are listening to me on interactively, but the way to do a truth table would be this. We're going to have two values, two Boolean variables, one's called A and one's called B. Now, we're going to write down all the possibilities for what A and B are going to be. They're either both true, A is true and B is false, B is false, A is false and B is true, or they're both false. There's only four options. Truth table. Welcome to Math 10005 or Comp 1600 or maybe high school maths. So now, what about A and B? If they're both false, whoops. Oh, come on, where's my thing gone? Oh. Ruin that somewhat. Uh-oh. Oh well. If they're both false, the answer is false. One of them's true, A and B is still false. This one's true, that's still false. And this one is true, only if they're both true. A or B, they're both true, A or B is true. Left one's true, that's true. Right one's true, both true. Both false, that's false. So these are all of the answers to those two operators. It's one of the cool things about Boolean algebra, Boolean logic, Boolean algebra, Boolean programming language sentences or statements. There's only a small number of possible outputs, so we can tend to be able to write them all down. Okay, well, we're going to do a demo in a minute, but just remember what we're going to do. Here's just a bit of setup for our demo. I'm just going to copy that into my P5 sketch. I've got a P5 sketch on another page, or the web editor. Hopefully you can see this. I think it should be visible to everyone. And we've got a nice love heart. So this is called unconditional love, this little sketch, because it's created this love heart and has drawn it for us. What's happening here? We're creating a canvas that's normal, no stroke, so we're just doing only the fill and setting a nice kind of slightly off red, a really nice color for this lovely love heart. Then in our draw loop, we're drawing a white background, drawing an arc, which will be this one, I think. Sort of a heart semicircle. Then we do another arc over here, that other semicircle. And then we carefully draw a triangle to form the bottom of the heart. I guess if you were going to be a little bit more careful with this, you would use some curves or more arcs to make it more of a kind of classic curved bottom love heart. But this is a fairly good love heart for 3 or 4 instructions. 1, 2, 3, 4. 4 commands, including the background. That's a nice simple love heart. And this is quite nice. It's been created with all of the variables to position it right in the center of the screen, rather than using the constant numbers for all of these locations. We're doing everything in relation to width and height, so that the love heart is perfectly in the center, and no matter how I change the screen, it's, if I restart the sketch, stay on page. Oh, I don't want that. Oh, well, I've got it now. If I restart the sketch, it will put itself back in the center. Okay. Now that I've introduced that, the conceit of the next part of the lecture is that, oh no, unconditional love can be very hard to find. So sometimes love is conditional based on certain inputs. I hope that's not the case for anybody out there listening to me today. I hope that you can find unconditional love, but sometimes things don't always go right. So what if we want our sketch to represent conditional love? We want it to do one thing some of the time and another thing the rest of the time. This is where we use the if statement. And this is really what I mean when I said conditionals before. The if statement is going to use a Boolean variable as input, and then it's going to make a decision as output. Here is the sort of basic format of the if statement. If in parentheses condition, some variable or some Boolean statement. We've got one code block here. Remember the curly brackets enclose a kind of block of code which we can loop or run at a certain time. In this case it runs that if the condition is true. Then we've got the else statement, the second part of the if statement, and then another code block do something else. Do we need both the if statement and the else statement? We actually don't. We can leave off the else bit. Don't need that. We can just do if condition and a block of code. We can actually have more of them. There's a way of, if you, instead of that, you put else and then wrote if, condition 2, you can check lots of conditions. Put a little squiggly bracket there, and then you might finish it off with an else to do something if all else fails. We can use that final condition. But let's try it actually. Here's we'll try in a second. Here's just a real version. We've got our Boolean variable called the sky is blue. And if that happens, we're going to draw an ellipse. Else, we'll draw a rectangle. So this is not a very useful artwork, including a conditional, but it's an example of one. Okay, back to my conditional love sketch. What is my condition going to be based on? Let's try this one. First of all, I'm going to just give myself some space over here. And maybe I always want the background to run. And then at this point, I'm going to say if mouse x greater than 200. Whoops. And then I'll put the curly brackets around all of this code down here. This P5 web editor, it's similar to VS Code. It's handily selecting the opposite bracket when I put my cursor on them, which is a really helpful feature just to make sure you're on the right track. I wonder if there's a way to tidy this up. Oh yeah, tidy code. Oh, well, that's pretty, isn't it? Now it's done all of my indenting for me. Sometimes there's aspects of programming which are sometimes not required, but they're nice to put into your code to make them easy to read. And one of them is what we call indenting. So I've indented, this is now indenting to 2 characters. After my function, every time I've got a curly bracket, it puts everything inside that block of code pushed in by 2 characters. And there's been a great battle over the history of computing between people who indent with spaces or tabs. Don't get anyone started on that one, or you'll regret it. Okay. So now I can run my code. As you can see right now, we don't have anything displayed. Well, why is that? My mouse X is off the left-hand side of the window, so it must be less than or equal to 200 and not greater than 200. So if I now move my mouse in, at one point I'm going to cross the 200. Oh, there's my heart. Cross the 200 barrier and my conditional love heart shows up. Let's use one of the else constructions. Instead of drawing a love heart, I'm going to draw something else. I'm going to draw a boring ellipse. 50, 50, 150. Oh, I'm going to put it in the center. Why not? Width divided by 2. Height divided by 2. And I'm going to make it pretty big. 250, 250. So now all the time I've got my ellipse, and when I make it a bit bigger so you can see that the ellipse is definitely disappearing. 450, 450. So sometimes there's a heart, circle when my mouse is to the left, sometimes there's a heart. Let's use one of those more complicated Boolean statements. So far I'm just using quite a simple thing. Mouse x is greater than 200. Maybe I want mouse y greater than 500, or less than or equal to 500 actually, that'd be fun. And I'm going to put them together, I'm going to combine them with the two ampersand symbols to get me that nice AND operator. So far I've got my circle, which always happens. Move my mouse. Uh-oh, something went wrong. A mouse. There's an incorrect variable there. That mouse variable doesn't exist. That was funny that happened actually, because P5 only got confused after mouse X was greater than 200. So you can see that it's not even bothering to check mouse, the second part, anything after the AND, until the first part is true, which is clever. Okay, back to this. This should work this time. So when I move across that X equals 200 barrier, changes to a heart. But if I move down past 500, we go back to a circle. Maybe we'll do an else if down here. Else if mouse y is greater than or equal to, or greater than 500. So now we're going to draw nothing most of the time. But if mouse y goes past 500, we'll draw that nice circle. And if I'm over here, in this quadrant, we'll be drawing a heart. So there's some basic ifs and elses. Sometimes we call it if then else. I almost said that, but we don't have a then thing being written in JavaScript. If then else means, well, if this condition, then you run this code, else you run this code. So sometimes there'd be a then. In some programming languages, there'd be a then bit of text that has to be written before the first bit of code to run. Yeet. Well, you can get deeply into Booleans. You will have to in your week 4 labs, so don't go mad and start taking another course. Other things will happen. So some previous lecturer had some good jokes about taking courses about love. You can take Psych 1003 if you want to learn about love, I suppose. I'm not sure that Psych 1003 is really going to help you understanding mind, brain, and behavior. If you're having love problems, unfortunately that's beyond the scope of what me and the tutors are able to help you with in Comp 1720, although we can help you to create love-related artworks if you wish. Here's some ideas of what Boolean variables could be used for. We've done a lot of stuff with the mouse X and mouse Y, but you also might want to keep track of whether something is being clicked or not. You might save a Boolean variable somewhere, or if something's finished, or you could, you might use these variables to save some states about what's happening somewhere in your code so that it's easier to read and track down what's going on. Oops. There's more stuff you can look at later about P5, JavaScript. I'm just going to take a sip of my water and we'll talk about loops, iteration and loops. I might put myself on the other side of the screen. That'll be fun. Ooh, I'm on the left side. These are fruit loops. These aren't the kind of loops we're talking about. But I guess one of the points of this slide is to say, well, so far we've had exactly one loop in our programs, which has been the draw loop. It's a loop which is already set up for us. But now we're going to learn how to make your own loops. And at that point, we're going to have lots of loops. Much like these fruit loops that are on the screen in front of you. There will be many loops. And that's where things start to get tricky with coding. So keep an eye out on it. You've already seen one loop, the draw loop. But we might want to do something multiple times within a draw loop. Ooh, that's where it gets interesting. Here's the first. We're going to look at two kinds of loops. I'll just say at the outset. One's called while and one's called for. Why are they called while and for? Well, it's to do with, the while and for bit describes kind of what the loop does. Let's talk about this while loop. So you might have a condition and like mouse x greater than 100, sky is blue, C is red, something's not finished, user hasn't clicked yet. While that condition is true, you might want to do something over and over and over again. While a condition is true, you might want to take a certain action. And that's what the while loop lets us do. So while something in those parentheses which says condition, while that's true, we should be taking an action. It's a very simple loop. This is a great one to learn first. And probably it's the loop that you could hang your hat on this loop. You don't need more than while loops if you don't want to go any further. Does this look familiar? Well, because it looks familiar because it looks a lot like the draw loop, right? The draw has sort of function at the start of it, then it just has draw, then parentheses that are empty, and then a open bracket, close bracket. So it's almost the same as your draw loop. Here's an example, human language intuition. While Agatha is sitting, we're going to draw circles on a slide. This is great. This example is great because we've started to define a function as well as a condition. So you'll get to learn how to do this next week. Drawing circles on a slide, someone might have defined their own function to take some actions or a group of actions that have been put together. And they've also got their conditional set up, a conditional variable, Boolean variable. And now the while loop can be very simple. It just has to have the one conditional statement and the one action that it takes. While triangles have three sides, we take that action. Well, this one's always going to be true, right? Unless we have dramatic changes in the way that the world works. So in this case, this is what we would call an infinite loop because it will never ever change. Infinite loops are sometimes bad in programming. People think they're bad. I guess when I was first learning first year programming, that was the advice given. No infinite loops, that's going to screw everything up. But in fact, we already have an infinite loop in P5, the draw loop. Well, it's almost infinite. It's not infinite if you use the no loop command, that'll stop it. But your artwork keeps on running through that draw loop again and again and again. An infinite loop, it never stops. So some infinite loops are good, they're useful. In this case, this infinite loop might be bad because if we suppose we had our draw loop, I've gone a bit abstract at the moment, but you've got the draw loop, draw, func, etc., draw, and then inside that draw loop you had this infinite loop, well, what's going to happen? Your code will start here, it will get inside the while loop, it'll run this code, then it'll go back to the top, then it will keep going there, and you'll just have this infinite process over and over again. Will you ever get down to here? I think we might be a few minutes behind on the output version to you folks. But if you're in an infinite loop inside your draw loop, you'll never get to the end of your draw loop. And that could be a problem because then you sort of expect that your draw loop is the only infinite one. So the draw loop being infinite is okay as long as loops that you have inside it are not infinite. We only want that to happen like a few times, 3x. So this is probably a bad idea. No, don't do that. No triangles have 3 sides. Oops, delete my Blackboard stuff. Here's a working example. We'll just have a look. We've got a variable called count. Let count equal 0. And then we're going to do a logical comparison. Count less than 5. And we want to take an action. So while count less than 5, we draw an ellipse. In fact, I'm just going to make up a new one. I don't want any of your pre-existing, non-creative examples. I'll make a similar one. New sketch, start again, delete everything. It's one of the fun things about coding in P5 is I hope that you have the feeling that you're never afraid just to make a new thing. Because every week we're making a lot of new things. This is not a course about making like one massive project over the whole course. You do a major project, but I hope that you get the idea of making lots of tests, lots of sketches. That's why we call it a sketch in P5. It's the whole language of this, this framework, this way of learning to create art with code, suggests to you that you ought to be trying things out, making sketches, not making final decisions. Let count equal 0. There's my variable. While count is less than 5, we're going to do some stuff. And the stuff we're going to do is make an ellipse. I'm going to put it in a random place. Random width. Random height. And it's going to be 150 in width and 150 in height. Okay, what's going to happen if I press go at this point? What's going to happen if I press play on my sketch? Let's give it a try. You never know until you try it. So far, I did click it, nothing has happened. Why has nothing happened? Probably just crashed my browser as well. Stop that page. Oh, stay on page. My browsers went very unresponsive. I couldn't see what was going on. There was nothing displayed. Why was that happening? Because I was stuck in an infinite loop. While count less than 5, count is equal to 0. Count is less than 5, draws an ellipse, goes back to here, count is less than 5, draw an ellipse, over and over and over again. We never get to the end of the draw loop. The browser gets very confused about what's happening, why nothing is stopping, and we don't know why it's not displaying our code. If you're on a laptop, you'd probably hear your fan go because the browser is trying to draw an infinite number of ellipses and it can't handle it. Let's get out of an infinite loop. Count equals count plus 1. I'm going to assign a new value to count, which will be 1. So that means that I'll draw an ellipse, count equals 0, draw an ellipse. Now count equals 1, draw another ellipse. Now count equals 2, draw another ellipse. Count equals 3, draw another ellipse, up to 3 ellipses. Count equals 4, draw another ellipse. Count equals 5, draw a 5th ellipse. Oh, count equals 5, and we stop. So we're not going to get to count equals 5. So we should have drawn 5 ellipses, 0, 1, 2, 3, 4. When count's equal to 0, 1, 2, 3, 4, each of those times we go start the while loop. We draw an ellipse. And then on the 6th time we go through the while loop, count equals 5. Count less than 5 is going to be false. So instead of running the code in the while loop, we stop. Let's try our code, see what happens. Ooh, it's drawing a lot, but I want to do no loop, so I really should have done this in the setup loop. I just want 5 ellipses, please. There we go, 5 ellipses. 1, 2, 3, 4, 5. Draw another 5 ellipses. Another 5, another 5, another 5. Ellipses for everyone. You get an ellipse, you get an ellipse, you get an ellipse. Whoops, I'm doing that for some reason. Don't know why. Stop that. Okay. So what do you need to remember about while loops? Well, I'll just put some comments in here. Hopefully you can see that a bit better. Conditional goes here. Note well, NB. Conditional code doesn't run unless conditional equals true. So it's the while loop checks this conditional and then it runs the code. And if the conditional is not true, the code's not going to run. Okay, and then NB, I'll put at the end, note well, careful of infinite while loops. Danger. Danger because, you know, your browser, you could be confused as to why your code is making nothing. If you have an infinite while loop inside of your draw loop, you won't see anything on the screen, or you may see half your sketch work, the second half doesn't work. Your fan may start spinning. Things may not seem to work the way you want them to, and it can be confusing. And what I don't want you to be is confused, because that means that you stop being creative. I suppose I want you to be confused enough, but then find a way through that confusion. Okay. Oh, there's another one. What's this one do? A second while loop. Let's just look at it for a second and see what happens. First, we've got a slow frame rate. Frame rate is 5 frames per second. So that's interesting. Then we're going to draw something. We'll do our draw function. Background's 30, sort of a gray background. A variable called x. While x is less than width, we're going to change the color to be a random color, partly based on the value of x. Then it's going to draw a rectangle of a random width starting at x and at the top of the screen with a random height. And then we add a random value to x. So hopefully you watched last week's lecture on randomness. Let's just have a look at what this does. Ooh, that's a nice one. Let's stop it, we can have a look. Oh, what? I want to stop it and see the see the code to stop. So in this one, we've got this value called x that we're saving. Let x equal 0. And so we're going across the screen from left to right, drawing rectangles. I might put a no loop down the bottom just so we see one iteration of it. One run through the draw loop. So x is getting slow over this while loop. X is going up and up and up until it goes off the edge of the screen. And at that point, we stop the while loop and we start the draw loop again. If for all the x's before that, we're going to choose a random color, somewhat based on the x location, and draw a random sized rectangle, but not too big. So this is a nice artwork which is combining some randomness, combining some loops, and creating something which is pretty interesting, visually interesting. Here's a little shortcut you might not know. This is the same as x equals x plus random 10. Oh, it's one of these little shortcuts that were designed to make programming a little bit easier. We do x equals x plus random 10, or x equals x plus something, so much that we've got a dedicated little shortcut for it, plus equals, but you don't have to do that. There's another very simple one, x equals x plus 1. You can write that as just x plus plus. Something plus plus is usually means to add 1 to it. All right, back to my lecture. Where are we at? Looping tips. I gave you these tips before, but I'll give them to you again. Make sure that the Boolean expression will evaluate to false at some point, otherwise you'll loop forever. We don't want that. We saw what happens. It's bad. You probably want to have some variable that you're modifying in the loop, and then when the modifications are done, the expression in the while loop, the condition at the top of the while loop should be false. So in this case, our variable to modify in the while loop is x. And inside the while loop, we're changing what x is. So this while loop is definitely going to execute a certain number of times. It can't go on forever. Even if we only add one each time. I suppose if we add 0 each time, it could go on forever, but it's unlikely to do that. It will eventually, x will eventually be more than width, and then our while loop will stop. If we were using some external variable, x equals mouse x or something, that could lead us to an infinite loop because it's an externally controlled thing. It's not something which is controlled within the loop. So you've got to be careful with that. It's not going to be a good solution. It could lead to infinite looping. When writing a loop, look at your code, be the computer. Think about types and flow. What I'd like to suggest to you is that there's 2 ways to try out some code. One is the suck it and see approach, which is you just try it, write it, see if it works. Sometimes you find out that your code doesn't work. And at that point, you kind of have to go through your code very slowly. It's like the intellectual approach. You're going to think through your code. Make sure you know what each line does. Make sure you know what decisions are made at each point, where the while loops are, what the conditionals are, and try to imagine what the values of x are going to be. That's a skill. That's something that takes some practice, and hopefully you'll learn that as we go through the labs, but it's not as easy to just to think through your code and be the computer, like it says on the lecture slide. But you need to use both. I also don't want you to be the type of programmer that is only thinking through the code and never wants to press play until everything's perfect. Right? This is supposed to be sketching, it's supposed to be spontaneous and interactive and iterative. So you're supposed to try it a lot of different times as well as be the computer. Where are we at with the chat? Sorry, I've lost a few. Ooh, someone's asked why are we controlling the frame rate in that sketch. Why are we controlling the frame rate? I think because so that you can see what these blocks are looking like within each frame. So if I just get rid of that no loop, it's kind of nice that we can get a bit of an eyeful of these blocks. If we just cut this out, it goes to the maximum frame rate that P5 will be able to handle with this browser. Yeah, it's just looking a bit annoying, right? I think it's probably running at 30 frames per second, something like that. I'm trying to. Yeah. It makes your eyes like want to turn away. 10 frames per second looks okay. 1 frame per second. Moving slowly. You know, frame rate is something you're allowed to control in P5, and sometimes it can actually help, or it can help you communicate an artistic idea to have a slow frame rate. It doesn't work for every type of sketch, but I would encourage you not to say that you can never touch the frame rate. It's something that, it's a part of P5 that's open to you as an artist to use. The second type of loop, this is the one which is a little bit more complicated than a while loop. It's not much more complicated, but it's giving you a little bit of help to accomplish certain loop types. So in the previous slide, I was suggesting that you would often have a variable or multiple within your loop, which you're checking every time and changing. They're the kind of the loop variables that go into the loop condition. The for loop gives you a chance to set up this process in the very first line, which can be handy sometimes. So if you want to do something a certain number of times, say you want to take an action 10 times, we can use the for loop to put all of the information of what we want to do 10 times in the block, and then the counting part stays outside of the block. So for let I equal 0, I less than 10, I equals I plus 1. So we've got 3 little statements here, all in a row, with the semicolons in between them. This is the value variable definition and assignment. Here is the comparison. That's the same as the only one we had within the while loop. That's the conditional variable, or the condition that means our loop will keep going. And here's the change of the variable. So define var, check the var, and change the variable. You can do the same thing with a while loop. It's just going to look a little bit different. So we would start with var or let I equals 0. Then we would have while, I less than 10. Then we've got our code to do, loop code. And then in the very last thing we do is I equals I plus 1. Okay, that's got to be last in the loop. So this is the same thing, right? A for loop can be expressed in a while loop. It's just kind of a more compact way of using it. I love for loops. They're very useful for me as an artist using P5. I will use for loops a lot in all of the examples I do in lectures. They don't have to be something that you use unless you want to or find them useful. You'll have to practice them as part of your lab work, lab tasks. But they're not, they can be expressed completely within while loops if you want to. I think sometimes I can remember myself forgetting what the order is for these 3 different little commands within the for loops, first line of the for loop. Sometimes that can mess with my brain a bit. There's different programming languages do for loops in slightly different ways, which can also confuse me, or I forget how to do them. But they're very useful, and you will see me use them a lot. In this case, we've got the variable that we're using to loop over, I. It happens to be given that name I, and often people with for loops use I as the variable. There's no reason you have to use I. It could be jellyfish. It's just a variable. The reason we chose I, that's just sort of tradition. It's often people use I. If they've got 2 variables they're looping over, sometimes the second one will be called J. I think programmers have taken too many maths classes. That's why we use I and J. It's like what we would use in maths for matrix multiplications or something. But the variable can be jellyfish. It can be senator. It could be creative. The word creative. It could be anything. I'm trying to think of dumb words to use for a variable. I guess if you use I, the advantage of that is that anyone later who looks at your code, including yourself, will know that that is supposed to be the loop variable, because we traditionally use it for. Someone's suggesting that I could be for index. That's true, it could be for index. But when we see an I within some code, we tend to say, oh, that's a loop variable, because you might actually use the I within your loop code. You can use it in there. You're allowed to do things with I, like it could be the size of an ellipse or something. I plus 100. Okay, for loops, you'll see them as we use them. Differences between them. Oh, exactly the thing I typed out. Here's the while loop, which is the same as that for loop. It's going to do exactly the same thing, just a slightly different way of writing the same code. Recap for today, code theory recap. Well, we've breezed through a lot of work today, haven't we? Got a few slides left, but we mainly talk about the assignment for the rest of the lecture. We get our Boolean expressions and if statements let us control the flow. Which block of code do we use at a certain time? And we've got loops, the for and while codes, that let us repeat blocks over and over again. So you're going to get lots of practice of these in the labs. I keep saying, wait for the lab, wait for the lab, wait for the lab. We have a whole lab next week just basically dedicated to these things, and you will get a lot of practice. Do you need these code concepts for assignment 1? I ask myself rhetorically. Probably not. If you want to, you can use whiles and fors in assignment 1, or you can use if conditions. But assignment 1 is designed to be something that you can do entirely with what we've done up to last week. So using these loops is not necessary to do a great assignment 1. I know people do, often students do want to explore these things immediately, but they're not completely necessary. Further reading and watching, here's some docs about them. There's some nice videos about conditionals, while and for loops by Dan Schiffman. I think they're, Schiffman videos, and MD and JavaScript docs. I'll also point you to the textbook. I've just forgotten what, I should put the link in there as well, what page it is in the textbook that talks about these things. Now we're going to talk about assignment 1. So hopefully I'll put myself on the other side of the screen just to note that it's a change of pace. Just making sure everything's good over on my Teams. Oh, sometimes I run out of puff in these long lectures, but hopefully with a slight break, I'll recover. One thing I like about doing the lectures in Teams is seeing you folks interacting with me, talking. I know we've got a couple of really great talking folks. Avery said, "Oh God, not Psych 1003, not again." Yep, that's. I think often any field at university has those introductory courses, which can be a bit of a special experience for those who have to go through them. It's often the case for many different types. Someone's discussing the for in loops in JavaScript, which is really handy. We'll look at those different kinds of loops later, but we haven't done arrays, so we can't go through objects and arrays until we've understand what those types of things are, what those types of variables are. We'll do that a bit later in the course. I think week 5 we do arrays and objects, or maybe week 5 arrays, week 6 objects. So they're a little bit more advanced, but we do have other ways of using for, which are super fun. I love using them. Assignment 1, artist statement. Let's just have a little tour of Assignment 1's webpage. So your task here is to make a name tag. And sometimes I think we get people who look at the assignment webpage and they're like, oh, there's a lot of text here. This is a hassle. What's going on? Why do I have to read all of this? The reason there's a lot of text here is because we want to give you a lot of information to help you. It's not because we want to confuse you with multiple things. If you find something confusing, please ask about it on the forum. But also, if you haven't read the page carefully, please do read the whole page, because it explains a lot of stuff about what we're expecting you to do. It gives you a lot of help without having to ask for it in the FAQ. It gives you some submission checklists and submission processes, which really help you to make sure you've done the right thing. But here's the deal. Here's the spec, or first thing, which is what do we want you to do broadly? You're going to have to make a name tag. You're going to have to make it interesting, and you should be making it readable. It should be clear and easy to read. So you should be able to see your name within the name tag. Now the process is that you've got to have done your pledge of integrity. That's sort of a requirement for the course. You fork and clone the assignment 1 repo. You know how to do that. You make your interesting name tag, type the code in. Then you run the sketch while you're running the sketch, if you hit the spacebar, there's a bit of code already in the sketch.js file. Hitting the spacebar will save a still image of your name tag, nametag.png. And what I want you to do is put that nametag.png into your assignment 1 repository, add that, that image and commit it to your repository as well. So that image will be part of your submission. And in fact, when you upload the assignment into GitLab, you push it, you'll get a little cross or a tick to check whether there's actually an image there. And if you do have a file called nametag.png, it gives you a tick just so you're reminded to do it. But that's neat because we look at that image alongside your code as kind of your definite version of your name tag. So it's a really fun thing to have listed, and it gives us something to put in our name tag gallery. So requirements for your submission. Your submission must include the nametag.png file, the code in that sketch.js file, that's the code that produces the file image, an artist statement.md, so it's a max 200 word statement describing your artwork, and then a file called statementoforiginality.yml, and that describes any inspiration, code, or assets that you use for other places. That's basically your references for your assignment. So if you have borrowed something from elsewhere, it needs to be in statement of originality. Now, the artist statement is something which can be a little bit tricky. Oh, sorry. Someone's asked, will the code quality be marked? I'm going to get to that in a minute. Artist statement is a short, max 200 words artist statement. This document, you write it in the first person, and it should answer this question. What are you trying to achieve with your name tag as a work of art? You're not going to get a separate mark for this, but it's important to give us some context for interpreting your artwork. It's your chance to tell us what you've done, and tell us what to give you marks for, right? Basically, right? If you have done something that's amazing with this really interesting inspiration, tell us all about that, and that will allow us to more accurately understand where your art came from, what it's based in, understand some of the context about it, that will allow us to give you a great mark. We know from our discussions of defining what art is, that art is not just what's on the page, it's a context of understanding around it. So this is your place to put that context. Now, there's a bit of question is how is it marked? I think that was, how is it marked? I have it in the main FAQ. How do you mark assignments? I'm going to talk about this in a minute, but we'll just get back to that. So here's the artist statement again. What are you trying to achieve with your name tag as a work of art? What's the inspiration? What concepts are you trying to explore? How have you tried to balance the goals of interestingness and readability that we've given you that can sometimes be competing goals? Discuss that, 200 words, not a large document. What I don't want you to write in your artist statement is a line-by-line explanation of how your artwork was created, like by saying, first in line 1, I set the fill color to green, and in line 2, I create a rectangle, and in line 3, I use a while loop to create 3 triangles. The reason I don't want you to do that is because I can just look in the code to find that out. The purpose of the artist statement is to give me the context that you haven't put in the code about what meaning you're trying to communicate, what you're trying to achieve artistically, and where your inspiration has come from. So here's an example. This is a name tag created specifically for this course, this lecture, by a former tutor, Kieran Brown. And this is an excellent, excellent name tag. It's just looking at it like it's super readable, right? Kieran. It's super interesting in terms of this pattern at the back. There's an interesting kind of constrained color palette, blue, white, and red. And it just looks cool. It's a different shape than you're going to be making because when this was created, the idea was to make a kind of rectangular name tag. We're making square ones, so you could use them as an avatar on Discourse discourse or teams. But, you know, when I look at this, I do think that it's super interesting, but I'm just start to wonder, well, what's going on with this background? That's really, really cool, but what is happening there? How has it been created? And I might look at the code, it might give me some interesting, it will literally tell me how it's created, but if I want more contextual information, I might look at the artist statement. So here's an artist statement that Kieran wrote as an example of an excellent artist statement. My name tag, first person, is inspired by one of the earliest examples of popular generative art. 10 print, sure, 205.5 plus random 1. Go to 10. And that was a one-line program for the Commodore 64 computer that would randomly pick between two characters, a backslash and a forward slash, and it would generate a maze on the screen. This program is an incredible example of the power of a simple generative process to produce complex imagery. This sketch uses the basic mechanic, a random choice between two alternatives, to produce the background of my name tag. Because the forward and backslash look very different on modern computers, I use P5 functions to create the classic shape of these characters. The blue color is inspired by the screen color of the C64, but I've brightened it for visual effect. For my name, I've chosen a font which has a similar computery style to match with the background and aligned it as closely as possible with the rows and columns of the maze. I've used a red outline to contrast with the background to ensure that my name tag is easily readable and also to create a focal point for the image. What a great artist statement. He's discussed the origins of his idea, what he was inspired by, how he made it, but he hasn't talked about any particular lines of code. And then he's also talked a little bit about the artistic decisions that he's made. Which referencing guide do we use ANU? Referencing guide is in our FAQ. Someone's, no. Look in the FAQ. People giving answers without knowing the answer. Do not do that in my lectures. There's a few questions here. I'm just going to address them as we go through them. Do we have anything to submit that explains the inspiration, intention behind the name tag? Yes, the artist statement. That's what you submit. Will the code quality be marked? That's about marking. And that's in fact in our FAQ. How do you mark assignments? I've got a question here. People ask this question all the time, and it's a very important one. So I've got five things I think about when I'm marking an assignment. Success in terms of meeting the assignment specification. That means, have you made a name tag? Is it interesting and is it readable? That's the assignment spec. The depth of the artistic process and conceptualization. I think that the one that Kieran submitted has a really deep artistic process and conceptualization behind it, which is great to see. Of course, Kieran was an expert in in generative art, so of course he should be, but everyone's at a different place with their artistic journey and their creative and code journeys. The code and technical quality and sophistication, and the clarity of communication and expression. So these ones, this basically is referring to, can I understand what is in your artistic statement and does it connect well with your artwork? If your artistic statement is not written in clear English, then I can't understand it. It doesn't express any of the other good things well. It's going to be hard to give that a good mark. Code and technical quality and sophistication, we do consider the quality of the code. So if you're doing something which is amazing with your code that I've never imagined seeing before, of course, that's going to be marked very well. But I've got both things, both artistic, or three things really, the artistic quality, the technical quality, and the depth of the process. So if you've only got one of these three, it sort of is, it pulls your mark back. What I'm asking everyone to do is to think of accomplishing all three. Great code quality, great technical quality, using all the tools I've given you over these last few weeks. Great artistic quality, using all the tools and inspiration from the art world we've talked about the last few weeks. And a great artistic process and conceptualization. So you've really thought about what it is you're creating. Maybe you've had a couple of attempts to iterate on it, make something, think, oh, it's not quite good enough, then make that idea better and get to a conceptualization which is really, really top-notch. And do something that meets the assignment spec. Does the code quality mark include things like commenting, neatness, etc.? There's no code quality mark. There's one mark, you get a mark out of 10. That mark depends on all of these 5 aspects. We don't separate them out. You get 1 mark out of 10. Things like commenting and neatness, I'm not going to pay a lot of attention to, but if you're doing something which is really complicated and you want to express to me that it is complicated, maybe putting comments in there is a good idea. So if you do want me to pay attention to your code, then having it neat and using comments would be useful, but it's not something that's going to lose you marks if your comments aren't there. How is this marked? I'm in the Kieran one. Well, Kieran's, someone's asked what mark would Kieran's ones get? This, for me, would be an HD. This is definitely in the HD category. It's something which is made by someone with a huge amount of experience behind them from artistic quality, and that really comes out in not only the visual appeal of it, but also the artist statement. So clear HD. I've got another example. I'm going to address some other questions in a minute, but this is another example. This one was made by one of our tutors this year. He was just experimenting with different ways of creating things in P5 and made several interesting kind of demo name tags. This one, he's made up a name, or he's borrowed a name of a musical artist called Claypex and created this name tag, which I think is pretty cool as well. He hasn't made an artist statement for it, but it just goes to illustrate one thing that he was thinking about. This is by Julian. Julian was thinking about the idea that it's really cool to see name tags where the text is not created by a font, but by using P5 to draw it. I think Kieran has done that as well. I think he's used P5 to draw the font, or maybe he's used a font, but Julian certainly explored using the text as an expressive part of the artwork. And then he's created a fairly simple background of these green dots. And this one, without the artist statement there, I think it's a bit up and down. I think this one would sort of be like high 70s or low 8s for the distinction, depending on looking at the artist statement. It's using sort of the basics we're expecting you to know in terms of P5 techniques, using ellipses, using colors, using transparency, using the flow of the code by putting objects on top of another. You can see he's drawn all of these ellipses and then drawn a line on top of them in white to cover them up. He's got some blurry thing going on. I'm not quite sure what was going on there, but it was an interesting, a really interesting demo attempt as well. So you can talk to Julian more about that one if you'd like. Just going back to my questions. Someone said, so the name tag can't be interactive. Wouldn't you know it? I've got a assignment 1 FAQ item about that. Where's my FAQ? The main part of this assignment is the image. We're going to look at both the image and code to mark, but the main thing is the image. So if you make something which is moving or it's interactive, like, that's cool, but that's not going to be the main content of your work. And if your work really relies on that interaction to, for instance, show your name, and then your image doesn't have your name in it, that could be a bit of an issue. People have used little tiny bits of interaction in their works, but it generally isn't a part of how we mark this one, because it's designed to be a static name tag. The outcome is a process that gets you a static name tag. Sure, make it interactive, but don't expect me to worry too much about the fact that it is interactive. Someone's asked, can we make it a GIF if it's interactive? No, you may not make it a GIF. I want to be really, really, really clear. The requirements. Number one requirement, a nametag.png file. The code in the sketch.js file. An artist statement.md, 200 words. A statement of originality with the references. These are the requirements. Do not deviate from these requirements. There are some things that I'm very open about. Make whatever kind of sketch you want to make, right? Do whatever. It's a very open-ended assignment. Do whatever within the constraints that I'm giving you of creating a flat PNG image called nametag.png. That's your constraint. Someone said, can they use their preferred name rather than a real name? Let's have a look in the FAQ. What name should I use? You should use your preferred name. You don't have to use the name on your passport. You don't have to use the name on your driver's license. You don't have to use the name on your birth certificate. You should use the name that you want to use, whatever that might be, for whatever reason. Some folks will have put preferred name into their into our systems at ANU or into their pledge of integrity. Sure, you can use that, but the name that you're expecting me to call you if I see you in the corridor, that's the name you should use. Does your name have to be in English? I guess it should use the English alphabet. That's a request here. Sometimes folks, particularly with different spellings of their names in different languages, might prefer to include some other characters, but mainly I'm looking for the English characters as well, English alphabet in some way. Can't be a GIF. What about sketches using frame count? Just need to make an animated one. Look, you can make it animated if you want to, but when you press spacebar in the name tag, the sketch.js file, when you're running it on a web page, it will save a PNG file, and that is the definition of what your name tag is. You must have a PNG file in your repo. That is what we're looking at for the definitive output of your work of art. Your code needs to be there. It shows how you got to that file, but the file is the output. I'll just go through the rest of these things. They're really, really good. There are really no late submissions. What? Late submissions? Sometimes people take courses where you can submit things after the deadline and expect to get marks for them. I'm here to tell you that within this course, in Comp 1720, there are no late submissions accepted for any assessment items. There are no late submissions accepted for any assessment items. If you submit an assessment item after the deadline, it will not be marked and you'll get 0 for that assessment item. Don't submit things after the deadline. This is why I will start to hassle you through discourse messages soon if you haven't started your assignment, because it's very easy to get started and submit something. And by submit, that means you've cloned the repo and you've pushed it onto GitLab. That's a submission. It's a basic submission or a start or anything like that. You can always push a new version, push changes. We mark the latest one that we see up to the deadline. And then after the deadline, you can push as many changes as you like, but we're not going to mark them. Is the size a fixed canvas, 800 by 800? Yes, the size is a fixed canvas, 800. Can I change the size dimensions of the canvas? No. You need to use an 800 by 800 canvas so that your name tag could be used as a profile image. One more time, if your name tag sketch is actually a cool animated thing, that's fine. Even good, right? Do whatever you want, be creative. Use your own process. But remember that the static nametag.png image that you commit is the main goal of this assignment. That's the main representation of your artwork. I don't know where to start. Here's lots of inspiration of where to start. Why is the deadline so close? This is not a very hard assignment. You don't have heaps of time. But the idea is to get something done in this course early to understand all of these processes and start the process of being creative so that you can refine your creative process and your coding process over the course, over your 3 assignments and major project. Last few slides. Artist statement tips. Don't explain your code line by line. Think of the overall goals and effect you're trying to achieve. Talk about what inspired you to come up with your design. Short and sweet's okay, but make sure you say something. If you don't submit an artist statement, the mark you expect to get will be very limited. It's not going to be 0 if you have some code there, but it's going to be very limited. Don't explain your code line by line. Read the website, the assignment website, and the main FAQ. That's all the slides I got. We've had a lot of questions. Anyone, oh, there's some more questions I forgot. Can we draw the alphabets by mouse manually? Smooth line like lecture 2. I think that would probably not be a very good idea because the goal with this assignment is to create the alphabets with code, not with mouse movements. So even though it would be a valid attempt at the assignment, but it's not going to be the best submission. I'm not going to say you can't do it. It meets the specification, it would meet the requirements, but if your code in sketch.js doesn't actually produce your name, I think that does limit it a bit. Just going through the questions. Sorry, I'm trying to read if there are any more unique questions. For people with EAPs, is the policy for late submission different? Yes. The policy for late submission is, in general, for any student, if you have a problem with an assignment deadline, get in touch with me as soon as you know and provide me with an explanation of what your problem is and ask for late submission. And often when people come to me with a genuine problem, the answer is, of course, you can get a late submission. If they're sick, have a doctor's certificate and the doctor said this person is sick on these days, I'll give you extend it by that amount of days, no problem. If someone has an EAP, an educational access plan, that means that they need some adjustments to the way that courses work to suit them because of various kinds of reasons, disability, a temporary disability or illness or something which is going on. In that case, you will always be able to ask for an extension. There's a maximum limit, I think, but in general, if you have an EAP and you think you need an extension, ask me. If you ask for an extension after the deadline, that's too late to ask for an extension. It needs to be before the deadline, well before the deadline, hopefully, but you know, things happen, people get sick at the last moment or something goes wrong. I'm always open to talk about extensions, but if you don't have an extension, a late submission will not be accepted. If we use some strange fonts, will it affect readability? Some fonts don't look like English characters. No, it needs to be readable. This is a weird font that Julian has created, but I can still read it. So if you don't know if your name tag is readable or not, ask your tutor, they'll tell you. All right, I think we're at the end of the question times. I would remind you to look at the FAQs, look at everything we've got. If you have any other questions, ask your tutor or ask in the discourse forum. Some people are posting questions in the Teams chat in between lectures, but what I find is that those questions kind of disappear, whereas ones on discourse forum, the questions and answers will stay there for the whole course. So if you've got an important question like what referencing do we use, great idea to ask that on the forum. Someone should put that on the forum and we can provide a great answer for you. Okay, I'm going to say outro and I'll see you folks on Thursday. Bye.